Hello, this is Fernando Campos and Iñaki Alonso from SAT Arquitectura, and we're going to do this presentation as a duo and talk about a project that you may already know because Elena Castillo in 2010 presented this. It's the ecological housing of the Entrepatios Las Carolinas project in Madrid. It's a project that represents different values. It's a vision which we refer to as triple balance, approaching the project by focusing on the relationship between people, social relations, the social relations of architecture, the relation of architecture with the environment, trying to adopt an ecological approach, a holistic approach, and also relations with the economy. It's a long-term project focusing on aspects such as circular, collaborative, and blue economy, these different types of economy that are developed in recent years. So that's the reason why we refer to it, or we describe it as a triple balance architecture project, which is a classic approach in sustainability. We'll focus more on specific aspects of the construction process of the Entrepatios project. Okay. Here you can see a longitudinal section of the building formed by a CLT cross-laminated timber structure. That's the CLT shell, 4 floors and a ground floor plus 3. CLT cross-laminated timber on reinforced concrete foundations with a basement outside thermal envelope used for parking. The transversal section in the layout shows you the floors, communication elements, entrance, stairways are outside the thermal envelope. We'll go through the different points indicated on the plans as the specific or unique points in the project in our attempt to obtain Passive House certification. The first are related to the building support, the building foundations, the shell, specifically the concrete floor base. The concrete floor slabs on the ground floor were supported on reinforced concrete block walls in the basement. The decision taken in the project for the floor structure was to insulate them on the exterior, in other words, from below, from the garage. In this way, each supporting point of the floor structure slabs on the walls would interrupt the thermal insulation, and this was resolved by crowning the walls with cellular concrete beams, as you can see on the photograph to the left at the top and on the right. It's perhaps difficult to see, but I think you can see the line. The next point, where the CLT facade was supported on the concrete slab, at the meeting point with the insulation below the slab. There you can see the meeting point, and the slab has greater projection at floor level. Therefore, the interruption with the concrete was resolved as follows. By inlaying or recessing in the concrete slab a series of cellular concrete blocks arranged, as you can see there in the photograph, the idea being to minimize as much as possible the discontinuity of thermal insulation and also increase fire resistance, which were required for the floor structure slab. In terms of the concrete supports at the base, there were many points where the support of the facade was established on a line where there was certain discontinuity in terms of the height. So, with certain beams, it was impossible to avoid this discontinuity, so we decided to extend the thermal insulation both externally on the right and also internally to minimize the impact of that discontinuity. And finally, as regards the support of the CLT facade on the base, here we can see the partition walls. There were partition walls on each side of the building where there were access points. On the ground floor it was exterior, And in the first floor, with the support, we would have the partition walls, which are crowned with cellular concrete beams. In this case, you can see the mineral wool insulation below the CLT floor structure. Another important challenge in this project was the question of airtightness or sealing in the CLT structure. Here in the photograph you can see the meeting point between the CLT and the concrete base. Since we had substantial problems leveling the slab, simple repairs were carried out with mortar to level. So the taping that was applied on those joints was reinforced with liquid membrane to extend the sealing surface right down to the concrete slab and not the retracted concrete. And another point which required a lot of work and control in the project was our concept of airtightness in the building. This was done or approached individually by property or apartment. But on the other hand, the living rooms in the building, in the apartments and some bedrooms, well, in those spaces we left the ceilings exposed. So on walls and floors, the hermetic line was on the interior, but in the ceilings it was exterior. In other words, it was the part of the floor and the property above, or the ceiling. So in these type of situations, ceilings exterior, walls interior, that ceiling line could not be achieved, and so we had to apply quite a lot of tape in CLT assembly work that could not be performed afterwards. And you can see this in the photograph. There was a piece of tape that was left before installing the panel. Or, for example, at points, for example, when we even applied this prior taping before assembly work and we couldn't close, then we carried out an experimental solution using a sealing tape or a sealant to just close that line. Another aspect of airtightness in the CLT structures in this project was associated with the climate in Madrid. Given the climate in Madrid, and since the building was left exposed until it was until the sate insulator was applied on the exterior, many cracks appeared. So for us, there was a lot of uncertainty about whether we would achieve airtightness, whether the building would be airtight. And very often, we can see that the developer also applied this type of taping. Even on the edging of this window, you can see the cracks appearing. This is due to the nature of the material itself. All we did here was perform 3 tests with the CLT installed and sealed and the carpentry installed to test behavior and performance. So we saw that this worked, and we decided to continue in the face of uncertainty. In the installation of windows, you can see the precautions that were taken. The yellow tape in the left-hand photograph to avoid the communication of interior and exterior air through these cracks. First of all, we taped over the wall frames, the window frames, and then you can see the framing of the CDT, white tape, one exterior, which is the black frame, with insulation foam for the joints in the intermediate area of the installation. Anchoring on the facade to minimize the interruption of the thermal bridge of the envelope and the sate system on the exterior of the CLT gave rise to great debate and discussion about whether we should do this using wood or metal. exposed to the exterior. Finally, we decided for the metal option, the metallic option. Therefore, we used metal anchors. These metal anchors separated the entire crown of the facade to provide continuity for the insulation across the entire facade with small thermal bridges at these anchoring points. That was the solution that was adopted for the yard. And then, in the case of handrails, those that were installed on the exterior, well, again, we also wanted to achieve the lowest possible thermal bridge. What we did here on the CLT facade was to incorporate wood wedges or blocks, also made from CLT, of the same thickness as the SATE. In this way, we could accept a thermal bridge, an acceptable wood thermal bridge, until the face of the CLT. This work took quite some time. It was complex. So the idea was to ensure that there were fewer anchoring points. It was a delicate point in the project. Well, another construction detail that was reviewed during the project were the roofs. Roofing was defined as a conventional roofing with waterproofing outside the insulation. Therefore, there would be a vapor barrier to avoid undesirable interstitial condensation. Well, there are a series of values. I think it was 100 meters was defined in the project with simplified waterproof sheeting. When undertaking the execution of the roofing, we realized that there would be complications. On the one hand, potential tearing of the sheet or membrane whenever operators would tread on the surface, or, for example, tears caused by metal screws and things like this. And that could be a problem in the rainy period. So we realized that the solution for the roof could give rise to problems. However, because we had time, we decided to change to an inverted roofing system solution. Therefore, the interstitial condensation problem could be resolved because waterproofing would be applied on the interior face of the insulation. This was taken into account in the thermal calculations, for example, the effect of wetting the insulation, and that was the decision taken. On the right-hand photograph, you can see one of the chimney shafts with brickwork. And as with the supports, you can see that the shafts were made with cellular concrete to provide continuity to thermal insulation in line with the envelope and also the interiors. Here's another detail of the construction work, which was actually changed during the project, during the construction work. The utility ducts or conduits, well, these were rather dense or congested, and they formed part of the thermal envelope. And the thermal effects are on the exterior. We're talking here about rain down pipes, television cable pipes, ventilator extractor pipes, individual ventilation ducts, and also ducts from kitchen hoods, which were then extracted to the exterior. All of this was defined at factory level, with plastering as a hermetic seal layer. But due to the nature of this project, we decided to change to a lighter structure or network and change plaster for a hermetic seal membrane or layer. The results were very good in the tests, and with, let's say, lower thicknesses, we were able to achieve the same insulation effect. And we believe that that was the right decision. And finally, I would like to just highlight one aspect of or one challenge of this project. It was more a strategic challenge than a construction one. From the very beginning, the developer requested, when it came to carrying out the first building tests, well, the developer asked for the entire air-water tightness line with all of the sealing points and all of the installations sealed and insulated. They wanted this to be open in the event of potential changes or tests in order to be able to correct anything if necessary. And although that's the way things should have been, in such a complex building, this was very, very difficult. I think the developer had a bad time during this stage of the project because it was difficult to meet deadlines, and it was very difficult to fulfill all of these requirements that were established by the developer. So we tried to propose different alternatives, like closing parts of the building or just closing the most strategic parts of the building, such as the office spaces where the majority of these type of piping and connections might occur. So to unblock the situation, we decided to do 3 blower door tests in 3 energy apartments as a representative sample, just to make sure that the work had been carried out in a logical and correct manner. And we decided to continue, just to unblock the situation for the developer. Okay, to conclude, I'd like to highlight one aspect which has been the subject of continuous debate since we started about whether or not we should certify. We convinced the cooperative to do a PH project, a passive house project. The cooperative has a high level of ecological awareness, and they were convinced about this approach, given the different energy efficiency and other measures that we could include in the project. But the budget that was established didn't give us much room to maneuver, so we started with very little margin. We completed the project and we consumed that margin. It wasn't much for such an experimental CLT project for passive house certification. At the end of the day, we're constructing at 750 euros per square meter, with all of the aspects that were included from a technical standpoint, but we exceeded the initial budget by 63,000, which is not that much, given that 30,000 of that amount went on moving a drain, around 2%. Well, let's say that's 1% for the drain movement. But our target was, if we were able to meet the price and the costs, then we could certify. In fact, we carried out a pre-audit with Energy House, and finally, well, we didn't achieve certification. We weren't within budgets, and certification was not approved. Another thing that we didn't achieve was something important for us, to be a building that produced no CO2. We wanted to compensate carbon used to build, but there was no margin to compensate. But again, one of our objectives is to make 0 CO2 buildings. But anyway, that's our philosophy, that's the way we work. Energy efficiency combined with the calculation of the carbon footprint and its reduction, and in buildings to decarbonize the economy, recycling water, using recycled materials, for example, plant-based paint, recycled textiles, and also volatile organic compounds, 20 kilowatts of energy in the building. Well, the building consumes the lowest amount of energy possible, the aim being to respond to society's needs. Well, finally, I would like to thank the platform for giving us the opportunity to share this experience, because at the end of the day, we weren't able to certify. But that shouldn't be a reason for not sharing this project. But it says a lot about the platform that we've been able to share this experience. And finally, I would also like to thank all of the suppliers and Fernando, first of all, who's worked really hard and has been the manager of this project, for their dedication and commitment and for their desire to develop projects of this type, which involve many companies, the developer, the insulation company, the watertight companies, the wood companies. All of the companies, all of the suppliers have shown great interest in developing these critical points. Well, we haven't been able to certify the building, but we're going to do much more, and we hope to be able to achieve Passive House certification in upcoming projects. Well, for my part, I would also like to express my thanks, thank Pep, and also thanks for attending this presentation. And thank you, Iñaki, for giving us the opportunity to participate in this project and also the cooperative as well. See you soon.